Hello. In this interactivity, we're going to discuss how angle affects the force on a wire. In this diagram, a short conducting wire is held at a fixed height inside the yoke, and a current is passing towards you along this wire through connecting wires. These connecting wires are not shown here. The two small diagrams on the left show overhead views of the magnet assembly and the wire. Let's select field lines to show the lines of force that pass from one block magnet to the other. You will see that the lines of force also appear in the upper small diagram and that they are perpendicular to the wire. According to Fleming's left-hand rule, which way should the wire in this arrangement move while the current flows? Yes, it should move upward. So if we select the vectors, the first finger points in the direction of the field, that is this vector. The second finger points in the direction of the current, that is towards you, and the thumb points in the direction of the motion, and hence the force is upwards. However, the wire is kept at a fixed height, so the upward force cannot move it, and the reaction force pushes down on the magnet assembly instead. This force shows up a mass increase to 0.6 gram on the balance. At the moment, the wire is at 90 degrees to the lines of force of the magnets. You're now going to investigate what happens when the wire is rotated. The upper small diagram shows an overhead view of its position at any time. Let's remove vectors, and let's drag the wire angle slider one notch to the left in order to rotate the wire so that it's at 60 degrees to the magnetic field lines. What happens? Yes, the balance reading is reduced from 0.6 grams to 0.52 grams. Now, let's change the wire angle to 30 degrees. What do you notice? Yes, the balance reading is reduced to 0.3 grams. And finally, let's change the wire angle to 0. What happens? The balance reading becomes 0. Now let's drag the wire angle slider slowly from 0 degrees to 90 degrees to see the changes in reverse. So as we increase the angle, the force of the magnetic field on the conducting wire changes with the angle between the wire and the magnetic field. The force is greatest when the wire is perpendicular to the magnetic field, as we see here, and the force is 0 when it's parallel to the field, that is, it has an angle of 0 degrees. That's all. Thanks for watching.